Unit 2, Lesson 8, example number 2. This example is slightly different than the previous one we did, and let's see why. So we are given that angle 1 and angle 2 are supplementary. All right, notice that these two angles are not one of the given angle relationships that are associated with parallel lines. Right? They're not alternate exterior, they're not alternate interior, they're not corresponding, and they're not consecutive same side interior angles. And again, they want us to prove that the lines are parallel. So this proof is a little bit longer. And we're going to use a property or reason that we haven't used yet, which will definitely be explored more in the next lesson, a little more thoroughly. But we can still use it because it was part of your vocabulary from Lesson 6, and it won't come into play until the end. So number 1, what do? We state the given. Angle 1 and angle 2 are supplementary. And that's given. 2, well, what does that mean? Angle 1 plus angle 2 equals 180. So you have a choice. You can say that supplementary angles sum to 180, definition of supplementary angles, whatever you'd like. Either one. Definition of supplementary angles. Okay, so I've used that information from the given. Now I need to develop new information from this diagram. So what do I see? I see that angle 3 and angle 1 are a linear pair. Definition of a linear pair. Right? It's what they look like. I can't just go straight to that they are supplementary. The reason being is that two supplementary angles do not necessarily have to form a line. Where a pair of angles that form a line are a linear pair. They have to form a line with those rays. Those outer rays have to be opposite. So we know that angle 3 and angle 1 are supplementary. Linear pairs are supplementary. We'll say angles. What does that mean? Angle 3 plus angle 1 equals 180. Definition of supplementary angles, where supplementary angles sum to 180 degrees. Alright, I now have two equations that both equal 180 degrees. Here's one, here's the other. So I can set them equal to each other since they both equal the same thing. So 6, angle 1 plus angle 2 equals angle 3 plus angle 1. Substitution. I'm replacing 180 in each of them with their appropriate equivalent. Alright, what are we basically trying to get at here? We're trying to get at angle 2 and angle 3 are the same. Right? Well, notice I have angle 1 on both sides, so I'm going to say that angle 1 is congruent to itself, and that is our reflexive property. Okay. So I've said angle 1 is congruent to itself. I've set these two equations equal to each other. Here is the new line of something you may not have seen before. Again, I want to show that angle 2 and angle 3 are the same. So in order to say that angle 2 is congruent or equal to angle 3, let's use equal here. So the measure of angle 2 is equal to the measure of angle 3. What did I have to do to line 6 to get that? I had to take away angle 1. So that is subtraction. Right? I'm subtracting equal amounts from already equal amounts. Right? I took away angle 1, which is equal to itself, and we know that both sides of line 6 are equal to each other because we set them equal to 180 in the lines above. So that's what subtraction means, if I take away equal amounts from equal things. Well, then we have angle 2 and angle 3 left, and if we look at our picture, angle 2 and angle 3, those are corresponding angles. So we can now say that line 1 and line 2 are parallel. And again, you have two options, but I'm going to save some time and write Converse corresponding angle theorem. If you didn't remember the name of that theorem, you have to explain what it says, which means if two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel.